here is a quick visual proof of the Pythagorean theorem, and why a squared plus b squared is equal to c squared. So I first, here, I draw a right triangle with side lengths a, b, okay, and the hypotenuse is c, okay, and then I duplicate it, and then I rearrange these. I duplicate it. No, I don't duplicate it. I make 4 copies of it, right? And then I rearrange it so that it looks something like this. Okay, so the side lengths of this large square has length, so a plus b is here, and then we're given that we have an inscribed shape over here, and this is indeed a 90-degree angle, 90-degree angle, 90-degree angle. This is a square, and I basically prove it by saying, okay, so here I have a right triangle, and I basically have it so that this part gets rotated 90 degrees counterclockwise to create this this shape, and then 90 degrees again to create this shape, and 90 degrees again counterclockwise to create this shape. Piece it all together so it looks like this. Now, okay, so why this special orientation? Because if I let this angle, the smaller angle, be phi and the larger angle be theta, and here I have this is theta, okay, then what is this angle? Well, it has to be 90 degrees, right? Because here from this triangle we know that the sum of the angles of an inside a triangle is 180, right? So if theta plus phi plus 90 is 180, then theta plus phi is 90, right? So here I have theta plus phi is 90, then 90 plus whatever this angle is 180, which means this angle has to be 90. So I apply the similar logic to here. So here's 90, 90, and this is 90 as well. Okay, so then I construct like a square, right, with side length c, 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 and then I have this larger square, okay, and with side length a plus b over here. Now I want to know what the area of this square is. I want to know what c squared. C times c is c squared. Right? I want to know what c squared is. Okay. So what is c squared? Well, to find c squared, right? What can I do is I can take the entire area of this entire square, right? Area of this entire square, and take away 4 times the area of this triangle, right? Because there's 1, 2, 3, 4. So if you take the area of this entire thing, and then subtract this away, subtract this away, subtract this away, subtract this away, I get the area of this inner square, the shaded part, c squared. So let's do that. So c squared is equal to a plus b whole thing squared minus 4 times the area of one of these triangles. Well, what's the area of this triangle? Right, it's just a base times height divided by 2. So base is a, height is b over 2. Well, or I can do b times a divided by 2. Okay, but in the end here, 4 over 2, what is that equal to? That's just equal to 2. But actually, before we do that, we should probably expand this guy out. So this implies that we get c squared is equal to a squared plus 2ab plus b squared. And then we take away, so 4 divided by 2 is 2ab. We see here that this plus 2ab minus 2ab, they cancel each other out. So all we're left with is that c squared is indeed equal to a squared plus b squared. And we're done.